Hello, I'm Mr. McBrien. This is Turing 9, Functions and Procedures. So yesterday we talked about documentation, getting ready to make our summative project. Today I'd like to talk a little bit about timing and nonlinear workflows. Okay, so the programs we've written so far have been extremely linear. We've either completed a function and stopped, or we've created an ongoing program where we do the same thing over and over again until the user stops the function. Okay, and this is really not typical of more elaborate programs. More elaborate programs will tend to have functions or subroutines that only trigger when they're needed. And for these kinds of workflows, we need to have something new called functions and procedures. Essentially, we need to accept that users are unpredictable, and sometimes things need to happen at unpredictable times. And based on a given situation, we may have to trigger given subroutines at somewhat random spots. For example, during word processing, a user might decide to highlight their text and trigger a spell checker program, for example. Depending on the kind of function that we need, the kind of subroutine we need, we would use a function or a procedure, and we'll highlight the differences between those. So, functions and procedures are really very similar. Functions return a result from their activities, whereas procedures don't. Okay, let's clarify that a little bit. So when we use procedures, we will declare them by saying, by opening the procedure, by saying procedure and giving the name. We'll write out some code that the procedure does, and then we'll tell Turing that the procedure documentation is complete by writing an end statement. And so any procedure, regardless of the size, will have that architecture to it. Now, once we want to call our procedure, all we have to do is simply write the line that is the name of the procedure, and this will trigger that subroutine. All right, so let's create a procedure pretty quickly. So what I'd like you to do is you can retrieve the code you wish, if you wish, about drawing shapes on the screen. But we're going to make some modifications to it. So we can you can either retrieve or rewrite the code to draw shapes on the screen. And this time we want to make that system a procedure. So we can simply put the definition line in place and the end line in place. Now, I'd like you to write an application that calls that procedure instead of running the code directly. And obviously this is an arbitrary example and it's not terribly practical. It would have been easier in this case to just write the code, but you can imagine if we need to call it as part of a bigger process, then this could be useful. Anyway, I just want you to get used to the shape of a procedure. So go ahead and modify or rewrite your code for your rectangle drawer in order to make it a procedure. And then use the single line to call your procedure. Okay, now if procedures could only be done as a single way of being run, they wouldn't be terribly useful. The good news is we can customize procedures for the situation at hand, and we can do this by using parameters. So once in a while you want to call a procedure that's the same as the last time and the same as every time you're going to need it. But more often you'll call a procedure and you'll need to give it some information it needs in order to customize for the situation at hand. So what we do is have the capacity to call that procedure, but give it a value for one or more variables such that it can use this and change its behavior. So these parameters, we can run the procedures with a given local variable value that works like a setting. And we declare the variable with the procedure, and then when we call the procedure, we give it a value for that variable. Okay, so I figured this was just as easy to show you some code that I whipped up rather than try to give generic terms for these things. So in my case, I've got a procedure here that draws a series of stars on the screen, and I want to have the capacity to customize this procedure for the speed at which it draws. So my parameter that's part of my draw procedure is the delay. Now, when I go to call my procedure afterwards, I can do that, and I give it the delay as the argument or the parameter that the procedure will use. And every time it will use that value for its delay. So you can see that right here where it's using that value. And that's what we call a local variable. So it's used within the procedure and only there. Okay, so what's your activity then? I'd like you to kind of mimic what I just did. Modify your shape drawer to prompt the user for the speed at which the shapes are drawn, and then draw your shape system either fast, medium, or slow. And it's key, I want you to understand, you're not writing out the code 3 times. You're not calling 3 different sets of code. Rather, you're using the same set of code with a given argument. Okay, and set up your system to draw the array of shapes, either fast, medium, slow, depending upon what the user has asked for. And if you want an interesting extension, go ahead and configure your system to let the user choose what shape is going to be drawn. You should find that to be an interesting problem. Okay, so there's my implementation with my pseudo-random colors of my stars. Okay, so now to talk about functions for a second. A function's just like a procedure, but instead of, for example, putting pictures onto a screen, a function will return a value that can be used in subsequent work. Okay, so the syntax looks something like this. We have a function. It accepts a few parameters, 1, 2, or more parameters. So those are part of the declaration of the function. The result is some calculation in brackets. And when we want to call it, we simply call it with values for the variables that it needs, for the parameters that it needs. So I'd like you to use the function command, going back to look at our dice rolling problem for a second. But I'd like you to design a program that has a function that rolls dice and calculates the total, but prompt the user for the number of sides on the dice. So is it a 7-sided dice, a 7-sided die, or are they 20-sided dice? So prompt the user for the number of sides on the dice and the number of dice rolls, and then call the function that with those arguments and output the total score of the dice. So the total score of all the rolls. So this is very much in keeping with the kind of thing that a function would do. Okay, to summarize, we can make subroutines in our programs. We can call them as many times as we wish and at any time in our user session. Procedures perform some function with or without arguments. Functions do the same thing, but they produce a value from the execution. For your homework, I'd encourage you to have a look at the excellent wiki that's cited here. It's got some good information on functions and procedures and some more detail than I went into here. And don't forget to upload the code from your activities to Google Classroom. That's all for today. Have a wonderful night.